Okay, so last time I added a workload to the master. So this is a workload. This is the master node. And so this is how I run the master node. Cluster master bash script. So what's the difference between my script and this script from the locally up installation guide? Okay, let's see the actual difference. Okay, let's see this way. So first, I added master load IP here, and this is another difference. Allow privileged settings. Using a container network interface plugin. Um, instead of use the local host IP address 127, but instead use my master node IP address. The Kubi API server host and the server IP use my load IP instead of the local host and the local host IP. For the actual node, the kubernetes, use my node IP instead of the localhost IP. And add this. So this is for cluster for the pod sider IP ranges. So when I create a pod, it will allocate the IP from this subnet. And I think this is using a load IP in the kubernetes. So I can show you the actual script. Let's see here, hack cluster master. my master node IP here. And start, I think it's start API, something like that. So this is a function to start up the API server. Yeah, I don't think I did much change here. Yeah, I think I changed. So yeah, here I set it to true, so to allow privileged. Yeah, see, those are the API server IP using my master IP. And so this is started the kubernetes, I think. Start kubernetes. Yeah. Start kubernetes on the master node. On the master node. Yeah, I think I added the node IP parameter for the master IP node in the start kubernetes function. Let us see what change I made in the start kubi proxy. So this is to start the kubi proxy in the master node, and here is to run the kubi proxy mode. What kubi proxy mode I want to run? I'm running the IPVS proxy mode, which is basically use a Linux virtual server in the kernel instead of using IP table, which is by default for the cluster services. Yeah. Let's see the diff again. Using CNI, allow privileged, Kubi API server. Wait, we haven't seen this. Let's see. Let's see this, where this changes. Okay, so this is to start up the Kubi controller manager. So when I create a pod, it will get the pod IP from this subnet. And yeah, I can talk about it. I can talk about this later. Why it's set up here. Yeah. So this is how I run the worker load. Oh, sorry. This is how I run the master node. See, this is a master node which itself has a worker node because it's running kubernetes and a kube proxy. So this is my worker load. Let's see what changes I made it to the worker load in the bash script. This is the worker load. Let's diff the worker load. Again, I'd add a master node IP here, a worker IP here. Same, allow privileged. Use CNI let plugin. API server IP. Use the master IP. The kubernetes host. Use my worker load IP. Yeah, there's some changes here. I'm not very familiar with the storage, but I had some error. Then I ended up set this to false. So this host name override, I set it to the worker load IP. So this is where I start up the kubernetes on the worker load. See here, I used kube configuration specifically for this worker load. Remember in the first session, I used the kube config bash script to create a kube config specifically for this worker load. Same thing for the kube proxy on the worker load. And this is some new setting for the kube proxy. Notice the cluster CIDR. So this is for the cluster services IP range, and not the pod ranges. IP table setting, I use the masquerade all. This is related to some network issue I have, and so I have to add this to work out the network problem on the worker load. So I'll explain in my network series. Yes. So because in the local up bash script, it runs all in one node, so it also runs a kube scheduler. But in my worker load, I only need to run kubernetes and a kube proxy, so I don't need to run kube scheduler. So I, remove those, and yeah. So here I added the start kubernetes here, and also add a start kube proxy here. So let's see the actual script. So this is how I started the kube proxy. on the workload, I added this thing for network problem I have, and I'll explain in later network series. The same thing, what could be proxy mode I want to run, and I run the Linux virtual server IPVS proxy mode. This is could be configuration for the workload. Yeah, basically I start Kubi proxy using this predefined YAML file for Kubi proxy. See here, it's Kubi proxy using this config. Yeah. So let's see how I started the kubernetes. Kubernetes here. Yeah, not much change here. I think that's pretty much it. Oh yeah, I think in the kubernetes, I also use the created a kubernetes configuration specifically for the workload. And okay, let's see. Start Kubi proxy. So this is how, if I'm running on a Linux virtual machine or Linux machine, start a kubernetes, start a Kubi proxy. So I added the start Kubi proxy here on the workload. See here it says start yeah. So here there is a like kubernetes only mode. In my command line, I start the start mode. I run basically mean only start Kubernetes on this workload. But in this Kubernetes only mode, I added the okay. Let's also start a Kubi proxy. So this is a Kubi proxy mode. Environment variable. I use IPVX proxy mode. I label daemon, which is meaning run it in the background. Yeah. So the worker node, or the master node, run in the background using IPVS proxy mode. This one I'm not sure actually I needed it now, because previously I run Fnano as a standalone process on the workload. So the Fnano process needed to talk to the etcd server which is running on the master node. So I forced the etcd server listening on all IP. So my so the Fnano process on my workload can communicate with the etcd to get the network configuration. But now I run the Flannel as a actual pod in the cluster, so the Flannel can get the configuration from the Kubi API server instead of the etcd server. So I think actually I may not need this. Yeah, but I just added it there anyway. Yes. So this is the how I hack the script to run a 2 workload in a Kubernetes cluster. I think let's end our this series.